In this video, I will show you my approach to crouching and standing up in Unity for an FPS controller. So this is just a demo of what I will be showing you. There is a plane for a ground and a symbol house model included. You can see I can move the character around and press the C button once to crouch and then press it again to stand up. I specifically made it so that you don't have to keep the button held down. Let me show you how I did this. The first thing I did was to import the standard asset package, specifically the first person character folder, under the project tab. I then dragged the FPS controller prefab into the scene view. Now it's important to note that this method I'm using does not work well with head bobbing active, so that'll need to be disabled under the first person controller script. I usually prefer to disable it anyway, so I didn't even try to include it into the code. The second thing that needs to be done is to decrease the near field clipping plane value. That'll just prevent your models from being clipped if the camera gets too close to them, as shown here. Then I like to keep all of my movement related code in one script, so I'll just be using the first person character controller script that comes with the model. This also allows me to use the references to the character controller and camera that come with the model. This method uses three variables declared over here. The first is a target height, which is a private float and contains the target height that we want the camera controller to be, which in this case is 1.8, which is the same as the default value that comes with the controller. The second is also a private float, which I call previous Y. And this just saves the previous Y position of the character controller. And that's important to prevent oscillations when we are doing lerping. The third variable is just a boolean, which I use to determine if we are crouching or not crouching. So it'll be true if we are crouching and false as we initiated when we are not crouching. So the code will be placed under the update function and is the code which is between those, which is being highlighted now. So you'll see all the code is pre-written here. I'll just comment out when we need it. So the first thing that we need to do is to determine whether the player presses the crouch key, and that I just do with the Input.GetKeyDown. And I use the C button, but you can use any key you wish. So what basically happens here is if the player presses the crouch button, the player will either stand up or crouch. So if we are currently not crouching, so if its crouching is equal to false, we set is crouching equals to true, and we set the specific target height, which is 0.9f. You can use any value you want. I just use half of the standing up target height. Then if we are currently crouching and the player presses the C button, we just set the target height for the standing height, and we set is crouching equals to false to dictate that we are standing up. So in order to physically crouch or stand up, we need to alter the height of the character controller. And this is done in this line of code where we say the controller's height is, we're going to lerp it between two values. And that just causes it to not be an instantaneous jump. So we're going to say Mathf.Lerp, and we're going to lerp from the start value is going to be the current height of the character controller, and we're going to lerp it to the target height, which we now said is equal to either 0.9 or 1.8f. And then as always, doing lerping, there's some type of a time variation included, and I like to use 5f times Time.deltaTime. So that creates a nice steady lerping function. So then if I go back to Unity and I press play, we can see I can move around. And then if I press C, we see I crouch down. And then if I press C again later, we'll see it stands up. But then if we zoom in on the player, we'll see if I press C, there we stand up. But then if I press it again, there, we can see that the camera doesn't really follow the collider anymore, the character controller collider. It has a slight offset above it. So in order to fix that, you'll see there, we need to go back to Visual Studio. So back in Visual Studio, we can just include the second line of code, which is basically going to transform the camera with the controller. So in this case, we are going to lerp the position of the camera's transform. So in this case, the position is a vector 3, so we're going to say vector3.lerp, and we are going to lerp it from in the original camera transform position. And then this is where things get a bit tricky. You can optimize the code, but I like to have it in one line. So we are going to lerp it to a new vector, which is going to have the same x and then the same z component values as the current camera transform. So we're not going to change the x or z, but the y is where things become a bit interesting. So we are going to use the character controller's transform position, the y variable of that position. And then we're going to add the target height, but half of that, because the character controllers is defined in terms of the middle of the character controller, not the top or bottom. So we need to add half of the target height. And then always I like to include some type of offset, which just ensures that the camera is where the eyes are normally and not just on top of the head. And then also just include the smoothing functions time delay. And then if I go back into Unity and I press play, just let it play, we can see now if I crouch down, the camera follows the character controller nicely. And if I stand up again, it follows it back. But then if you can see there specifically, if I stand up again, it sort of looks like the character is jumping a bit. So we need to fix that, and that's basically due to when we change the height of the character controller, it's changed from the center outwards, not from the top, from the bottom upwards. So we need to change that, and this last line of code is where that comes into play. So basically now we need to transform the position of the character controller while we are increasing the height, increasing or decreasing for that fact. So again, we are going to use vector3.lerp because we are transforming the position, which is a vector 3, and we are going to move it again from the character controller's current transform position. And now, similar to the previous case, we are having a new vector 3, and the x and z components are again staying the same. But the y component is where it again gets interesting. So here we include that previous y variable, and you'll see we again do. If we just go there, we'll see that if I instantiate it to 0, which basically is equal to not including that previous y, and we'll see later why we need to include that. But basically, if it's 0, we're not taking it into account whatsoever. So we need to add the target height, again divided by 2, because we're working from the center of the character controller. And then here we need to include the character controller's skin width, which is a little bit extra height that we need to take into account. Otherwise, we'll have some sort of oscillations, and that's where it comes from, that skin width under the character controller, which is 0.08 in this case. So if I go into the isometric view from the side, we can see that the character controller is not immediately on the ground plane, which is shown by that vertical line there by the mouse. So it's got that slight offset, which is equal to that 0.08. And then of course, if I want to, I can decrease that, and you'll see if I play, if I just click play, if I click the play button, we'll see that the character actually falls down completely to the floor. But then I can also increase it again, and we increase that height. So that's a height we need to take into account when doing the lerping functions. So I'm just going to revert that back to the prefab value. Just right click and say reset value to prefab, and then you'll see, just to show you again without any changing the values, we'll see that it's the same. So now we see that we can stand up nicely, we can crouch, but that's only while we are on the ground plane. So you'll see if we move onto that little step, we've got an increase in our height, but also we introduce some oscillations. Now those oscillations are due to us not taking into account the actual height that we need to be. So if we go onto the step, we add a little bit of height, which is not added when we are on the ground. So we need to take that into account as well. So if we go back to Visual Studio and we just comment out that previous y is equal to 0, and we add the top previous y line, we'll see that basically what we do there is we take the current transform position.y value of the character controller, and we add we subtract half of the height to get us to the absolute bottom, and then we also subtract the skin width. That'll give us a reference nicely to whatever we are standing on. So if I go back into Unity and I press play, you can see it still works fine. If I'm on the ground, I can crouch, and if I go up to the little platform there, I can stand up and there's no oscillations. Everything seems to be working wonderfully. So I can jump up and down, there's no oscillations being introduced, and everything works well with crouching and standing up again.